Hello friends. We will continue with the process of solving the numericals. We have already solved two problems. Hopefully, based on the instructions and based on the methodology which I have given, you have literally solved the problems on a piece of paper and you have got the results. As I said, maybe at the end I will share all these results with you and you can compare them. Now, I have also sent you photographs of the numericals, and there are a total of 11 problems. Now, if you go through these problems, you'll find that most of them are quite similar, and it is a matter of simple substitution and so on. So what I do is, of course, in problem number 3, you will find that fuel consumption is given in kg per hour. Okay, so it is 4 kg per hour. So you will have to divide it by 3600 in order to get in kg per second, and that again is a matter of simple substitution. Have some, you could say, be careful about the torque values and so on. Again, in problem number 3, the torque is given in Newton meter. Okay, so there is no question of W minus S multiplied by 9.81 and so on. That value has to be taken directly. That is, torque is 200 Newton meter. So there is no question of calculating W minus S into R and so on. T value is directly given. You can use this value of T, which is 200 Newton meter in the equation. Brake power is 2 pi T by 60 into 1000, and find out what is the brake power. And by looking at the values that are given, that is, it is a single cylinder 4-stroke IC engine which has a bore of, bore is nothing but, as I said, it is the diameter of the cylinder or diameter of the piston. We assume them to be the same. So it is 180 mm. 180 mm is 0.18 meters. Similarly, 200 mm stroke length is 0.2 meters. And the rated speed, that is the crankshaft speed, is given as 300 rpm and so on. So what I want all of you to do is, please solve this problem. Try to solve this problem on your own based on all the earlier discussions, and just check whether you will be able to solve. Because unless and until you solve some problems on your own, you will not be able to develop that confidence in it. So I have actually specifically marked a couple of problems which I will be solving today. You can see the photographs, because I have already sent a document of the same, but the photographs where I have numbered the problems or the numericals, that you can once again check. So today what I will do is I will solve problem number 4, problem number 6, 10 and 11. Okay, so these 4 problems I will solve because they are slightly different as compared to other problems. They are not difficult, but they are slightly different, that's all. So I will read out the statement of problem number 4. What it says is a 4-cylinder 2-stroke petrol engine develops 30 kilowatt at 2500 rpm. So you have to be extremely careful when you are reading out the statement. Okay, so whatever is given, let's say if I write it as data, then the first thing is it is a 4-cylinder and it is a 2-stroke engine. Okay, so it develops 30 kilowatt at 2500 rpm. Now, if we generally look at these kind of statements, there is always sometimes a certain level of ambiguity, because what do we mean by it develops? There is a small bit of a confusion whether we need to take it as indicated power or brake power. So generally it develops 30 kilowatt means that is going to be the you can say that it is the indicated power. Okay, unless and until it is very specifically mentioned that the brake power available at the crankshaft is so many kilowatt, and instead of that, if it is mentioned as it develops 30 kilowatts, we can take it as the indicated power. So it develops 30 kilowatt at 2500 rpm. So what I will do the engine RPM is 2500. That is the crankshaft speed. Then the mean effective pressure on each piston, that is PM, mean effective pressure on each piston, is 8 bar. And mechanical efficiency is 80%. Okay, so mechanical efficiency is 80%. Calculate the diameter and stroke of each cylinder with the stroke to bore ratio. Now, stroke to bore ratio is L is to D. This value is given as 1.5. And calculate the specific fuel consumption. That is, you are required to find out what is the value of M, specific fuel consumption. If the calorific value is 43,900 kilojoules per kg, so calorific value is kilojoules per kg, and the brake thermal efficiency is given as 28%. So you can see how low the brake thermal efficiency is. So brake thermal efficiency is 28%. So what you are required to find out is of course the specific fuel consumption and also the diameter and stroke of each cylinder. That is, you are required to find out L and D. Both these. Okay. Now, in some cases, sometimes I would suggest you can consider both and try out these problems. But if we start getting very absurd values, then we may understand that there is some problem or there is some questionable assumption which we have made. So initially I said it develops 30 kilowatt, which can be taken as indicated power. But as I said, it doesn't make sense. When something is getting developed, that means it is at the delivery end. Okay, so since it is at the delivery end, first thing what we'll do is we'll try to solve this problem by assuming that this 30 kilowatt is nothing but the brake power. Okay, so and then we will see how to move ahead. You can also solve this problem later on using 30 kilowatt as the indicated power and try to solve the problem. But my suggestion is whatever method you use, in case you come across this kind of a problem in the examination, you clearly mention what is the assumption you have made. Okay, so without which there may be discrepancy in the answers, and hence you may end up losing marks. And as I said, since this is a VTU question, it is quite important that we get the values correctly. So what I'll do is I'll assume this to be the brake power itself. Okay, so the total brake power is 30 kilowatt. Now, what is the total indicated power then? So what I'll do is I'll start with the solution. I'll tell you how to go about it step by step. So the total indicated power, how do I find this? We know that the mechanical efficiency is given as 80%. Now, which is nothing but 0.8. And how do we find out mechanical efficiency? Mechanical efficiency is nothing but brake power divided by indicated power. So that means we have brake power divided by indicated power is equal to 0.8, which is already given. So we can find out what is the total indicated power, which is nothing but the brake power divided by 0.8. So whatever value you get, that will be the total indicated power. Okay. So this value, this is nothing but 30 divided by 0.8. So once you use a calculator, find out this value, whatever you get in. So this same value you are going to write it here. Okay. Now you need to understand that because it is a 4-cylinder engine, that is the total power which is available at the crankshaft. 30 kilowatt is the total power, and we have found out what is the total indicated power. So all 4 cylinders put together, they are of power. But what we need to find out, or whatever equation we have, indicated power is equal to Pm into L into A into N divided by 60 into 2 into 2, whatever. That equation is for a single cylinder. Okay. So now what we have to do is, once we have found out the total indicated power, we will find out what is the indicated power per cylinder. So the indicated power per cylinder is this value, whatever this value is. Okay, so that is, let's say I write it as IP total divided by 4, because it is a 4-cylinder engine. Okay, so once we get this value, indicated power per cylinder, this we can simply write as indicated power directly. Okay, now we also know what is the equation which we need to use. See, the value of mean effective pressure is also given in bar, and it is per piston. So since it is a 2-stroke engine, we also know what equation we have to use. Okay, so we will use that equation. Indicated power for a 2-stroke engine is given by, since it is given in bar, I write it as 100 into Pm into L into A into N divided by, now we will only write it as 60, because we used to write 60 into 2, since that for a 4-stroke engine it was N by 2, but here we write it as only 60, and that 1000 has also vanished because the value of mean effective pressure is given in bar. So now this value we have already found out. Okay, that is whatever is the value, the total indicated power divided by 4 will give you the indicated power per cylinder. So write that value. So you know now the left hand side is known to you, is equal to, here what will happen, this is something which is quite interesting. So we will write it as 100, and the value of mean effective pressure is given as 8 bar. Then the stroke length is not given to us, and the bore diameter is also not given to us. So we are required actually to find out both of them. Calculate the diameter and stroke of each cylinder. That is what is asked. So what I do is, this equation is given to us. L by D ratio is given to us. L is to D is 1.5 means what? This means L by D is equal to 1.5, or L is equal to 1.5 D. Okay. So in this equation, wherever we have L, I'll write it as 1.5 D. I don't know the value of L, neither do I know the value of D. So I write it as 1.5 D. This is nothing but this L which I have written. Now A is pi D square by 4, so it is pi into D square. I'll write the value of 4 in the denominator, and N I have already know, which is 2500 RPM. And this entire thing divided by 60 into 4. Okay. So now we will have a cubic equation in D. Okay. So because we have a D here and D square here, we will have a cubic equation in D. This LHS you have already found out from here. So this value we will write it here. And equate the two, do the calculations. So finally you will get something like D cube is equal to some value. Okay, and this will be in meter cube. So take the cube root of that. Again, in a calculator you can find out the cube root. So whatever you get here, take the cube root of that, you will get the value of D. That is the bore diameter. You will get it in meter. Okay. Depending on the value, what you can do is you can multiply it either by 100 or by 1000 and write the final value in millimeters or centimeters or millimeters. So once you find out the value of D, then we know that L is equal to 1.5 times D. So whatever D you have obtained, multiply that by 1.5, you will get the stroke length. So you can find out L, you can find out D. That is what is asked in the numerical. Now one part of this entire thing is over. Now what we need to do is we need to find out what is the specific fuel consumption. Now if I use the total power, that is 30 kilowatt, and find out the specific fuel consumption that will be for all the 4 cylinders put together, because that is the total brake power. Again, if you divide 30, which is the brake power, total brake power, by 4, you will get the brake power per cylinder. But since all of them are connected, if I have 4 cylinders, all of them are connected to the same crankshaft. The crankshaft is delivering 30 kilowatt. So what I will do is I will take the total value. Okay, so I will take the total brake power as 30 kilowatt. So how do I find out the specific fuel consumption? What I do is I know what is the equation for the brake thermal efficiency. So the equation for brake thermal efficiency is given as, I will write this as brake thermal, which is equal to brake power divided by M into CV. So what is actually asked in the problem is this value of M is asked. Now the brake thermal efficiency is also given, which is given as 28%, which is again nothing but 0.28. Okay, so it is nothing but 0.28. So what I do is I write this as 0.28 is equal to total value of the power which it is developing, which is 30 kilowatt, divided by M into the calorific value of the fuel is given as 43,900. Okay. Now when I do this, I can easily find out the value of M. I can easily calculate the value of M. So M will be equal to 30 divided by 0.28 into 43,900. But this value which we are going to get, because we have directly used it, the value what we are going to get will be in kg per second. Okay, so this is going to be the fuel consumed by all 4 cylinders put together in kg per second. So whatever value I get, this value, if I multiply this by 3600, I will get the specific fuel consumption for all the 4 cylinders in kg per hour. So this value, whatever I have into 3600, will give me the units in kg per hour. Okay, so the specific fuel consumption is kg per hour. Now, if you want to find out what is the fuel consumed per cylinder or the specific fuel consumed per cylinder, what you can do is whatever value you get after multiplying this in kg per hour, divided by 4, because there are 4 cylinders, you want to find out how much fuel is consumed by each cylinder, divide that by 4, you will get the specific fuel consumption per cylinder. What is actually asked is calculate the specific fuel consumption directly. So you can actually stop at this value, only this value. But you can also add one more thing, that the specific fuel consumption per cylinder is calculated by whatever this value is divided by 4, because it is a 4-cylinder engine. Okay, so that is the solution for the fourth problem. As I said, please make sure that you use your calculator properly and get the values. You can't get very absurd values as such. So we, as I said, we have to think and then assume what value is given. They have not directly mentioned whether it is the indicated power or the brake power. It is just mentioned as it develops 30 kilowatts. Okay, so we really don't know what to take, whether to take that as indicated power or brake power. But if you do a little bit of analysis, we can understand that something is developing means that is the output. Okay, so since the output is nothing but the brake power, we have taken the brake power as 30 kilowatt, and then we have gone through the whole process. In some cases, what may happen is they would have specifically mentioned that it develops an indicated power of so much. Okay, so in that case, you have to use indicated power only. So that is the solution. Get the values, and I hope that you will come up with the right answers. So that is problem number 4 which I wanted to solve. Now we will go to problem number 6. As I said, I am skipping a couple of problems for two reasons. One is, of course, I want you to solve them on your own. See, for example, problem number 5 is an extremely simple problem where it is a 4-stroke diesel engine, which means again we have to consider that as a single cylinder only. Has a piston diameter of 250 mm, stroke of 400 mm, mean effective pressure is 4 bar, speed is 500 rpm, and the brake drum diameter, it is just mentioned, brake drum diameter is 1000 mm, which is nothing but 1 meter, and the effective brake load is 4000 newtons. Directly they have given the value of brake load. So that is W minus S is given in terms of Newton only. So take it directly as 4000 newtons. You can find out the torque. Torque is equal to W minus S into R. So R will be 0.5. That is brake drum diameter is 1000 mm, which is nothing but 1 meter. So the radius will be 0.5 meters. So torque will be W minus S into R, that is 4000 into 0.5, which is 2000 Newton meter. So use this 2000 Newton meter in the equation. Brake power is equal to 2 pi nt by 60 into 1000. You will get the brake power. And with the values given, you can easily find out what is the indicated power. And you are required to find out indicated power, brake power, and frictional power. There is nothing wrong in again finding out the efficiency. So I'll directly go to problem number 6 now. Now, what does the statement of the problem say? The statement says, of course, initially there is a small KV part which you have to clearly write. Define indicated power and brake power. Now, indicated power is nothing but the power which is generated inside the cylinder due to the explosion of the fuel. The pressure energy which is released by burning of the fuel will be exerted on the piston. So this total energy which is released and exerted on the piston, we term it as power, and that is called as the indicated power. Now there will be some losses. This energy will be transferred, this power which is generated inside the cylinder will be transferred to the crankshaft. So there will be some losses because of friction and inertia. Hence, whatever power is generated inside the cylinder will not be available at the crankshaft. So the power which is available at the crankshaft will be called as the brake power, and the difference between these two will be called as the frictional power. So that definition you have to write. Then comes the statement of the problem. A 4-stroke IC engine running at 450 rpm has a bore diameter of 100 mm, stroke length of 120 mm. The indicator diagram details are, see, yesterday I told you that sometimes the value of mean effective pressure is not given directly. The indicator diagram details are, area of the indicator diagram is 4 cm square, length of the indicator diagram is 6.5 cm, and the spring value is to be used is 10 bar per centimeter. Okay, so 10 bar, 1 bar is nothing but, if you look at this chart, okay, so 1 bar is 10 raised to 5 pascals. So 10 raised to 5 pascal. 1 pascal is nothing but 1 Newton per meter square. Okay, so 10 raised to 5 Newton per meter square per centimeter. Okay, that is what that equation you have to use. So very quickly I will write down those values. So you are required to find out what is the IP of the engine, that is indicated power of the engine. So the value of N, so if I say the data, the value of N is given as 450 rpm. Then bore diameter is given as 100 mm, and this 100 mm is nothing but 0.1 meter. Then stroke length, that is L, is given as 120 mm, which is 0.12 meters. Then the formula for the mean effective pressure is SA by M. So those values are going to write. The spring constant, that is the value of S, is 10 bar per centimeter, which is nothing but 10 raised to 5, okay, Newton per meter square per centimeter. So you will get the value in Newton per meter square. And area of the indicator diagram, this A is given as 4 centimeter square. Base length of the indicator diagram is given as 6.5 centimeter. Now using these, we need to find out the indicated power. So if you just close your eyes and recollect, if I want to find out indicated power, what are the values that are needed? I need the mean effective pressure, I need the stroke length, I need the cross-sectional area, I need the engine speed, engine RPM. So these are the 4 important values which I need. And since it is a 4-stroke engine, I will just consider it as a single cylinder 4-stroke engine. So it is not mentioned, so I will just write it as a 4-stroke. So to find out the solution, now what we will do is first find out what is the mean effective pressure. Mean effective pressure is S into A divided by L. The spring value is 10 raised to 5 in Newton per meter square per centimeter. A is 4 centimeter square and L is 6.5. So you will get this in Newton per meter square. Okay. So this value, mean effective pressure value, you have got it in Newton per meter square. You can find it out. So once you know the value of mean effective pressure, now there is nothing else, nothing great in order to solve this problem. You just have to use the equation properly. Since we have the mean effective pressure value in Newton per meter square and it is a 4-stroke engine, we have to use the proper equation. So I will write the indicated power as PM LAN divided by 60 into 2 into 1000. Okay, so PM value is in Newton per meter square, so I am using this equation. So this will be whatever value I have obtained here, that value. This PM, this will be the same value. Then L, we know the stroke length, which is 0.12 meters. So I write this as 0.12. A is pi d square by 4. That is. See, the bore diameter is 100 mm, which is 0.1 meter. So pi d square by 4, I write the value of 4. And the engine speed is given as 450 divided by 60 into 2 into 1000 into 4 kilowatt. Okay. So it was only 60 into 2 into 1000. I have now written 4 because that 4 is the area, pi d square by 4. This value is nothing but A. Okay. So once you do the substitution, PM value you have found out, write that value here. And once you do the substitution and use a calculator to find out the value, finally what you get is nothing but the indicated power. So indicated power will be so much kilowatt. Directly you get the answer. No, it is a very simple problem. The only thing is, as I said, the mean effective pressure value is not given directly. What you need to do is you need to use that equation, the mean effective pressure is equal to SA by L, and then find it out and use it in the equation. Okay, so there are another 2 problems which I will solve. That is problem number 10 and 11. Okay, so I will solve them now immediately. Okay, we will solve another 2 problems. Actually I wanted to solve problem numbers 10 and 11. But after reading problem number 11, you also can do it. You will find that it is similar to problem number 4, okay, which we solved in the earlier discussion. So except for finding out specific fuel consumption, rest all almost remains the same, where it is a 4-cylinder 2-stroke engine, develops 30 kilowatt at 2500 rpm, and the mechanical efficiency is 80%. The mean effective pressure on each piston is 6 bar. So you are required to find out the stroke length and the bore diameter. Okay, so it's almost the same. So here also you can assume that it is developing 30 kilowatt, means it is the brake power. So find out what is the total indicated power, that is 30 divided by 0.8, that is the total indicated power. Since it is a 4-cylinder engine, indicated power per cylinder you can find out, so divided by 4, and that value you equate it to PM LAN divided by only 60, because or 100 PM LAN divided by 60. Because it is a 2-stroke engine, that 2 will vanish from the denominator, and since the value of mean effective pressure is given in bar, so it will be 100 pm LAN and divided by 60. So this is a very similar problem. I suggest you can solve it on your own. So what I will do is I will solve the problem number 7 and problem number 10 now. Now problem number 7, which is for 8 marks and very interesting, actually very simple also. The following data are collected from a 4-stroke single cylinder engine at full load. You don't have to worry about what is the meaning of full load, half load and so on. But this is the data. Bore is 200 mm, stroke is 280 mm, speed is given, then torque on the brake drum, mean effective pressure, fuel consumed, calorific value, everything is given. You just have to substitute in the respective equations and get the answers. And there can be nothing simpler than this, okay, and it is for 8 marks directly. So I'll just write down the data and then very quickly tell you how to solve this problem. Okay. So we have a bore diameter as 200 mm, which is nothing but 0.2 meters. Then the stroke is 280 mm, that is L, that is 280 mm, which is nothing but 0.28 meters. Then engine RPM is given as 300 RPM. Mean effective pressure is given in bar, so it is 5.6 bar. Torque on the brake drum, that is the value directly is given. Torque is given as 250 Newton meter. Fuel consumed. Okay, so this is 4.2 kg per hour. Then the calorific value of the fuel is given as 41,000 kilojoules per kg. So you are required to find out mechanical efficiency, indicated thermal efficiency, and brake thermal efficiency. All, let's say, indicated thermal efficiency and brake thermal efficiency. Now obviously in order to find out all the 3 efficiencies, first what you need to do is you need to find out what is the indicated power and what is the brake power, and then we can find out everything else. Okay, so how to go about this? Since it is mentioned that it is a 4-stroke single cylinder engine, so what is relevant to us, what is important for us is it is a 4-stroke engine. Okay. Now we can find out the indicated power. Since it is a 4-stroke engine and the mean effective pressure is given in bar, we can write it as 100 pm LAN divided by 60 into 2, because it is a 4-stroke engine. So we will write this as 100. PM is given as mean effective pressure is given as 5.6 bar. The value of L is given as 0.28 meters, so it is 0.28 into pi into 0.22 square. The value of N is 300 RPM divided by 60 into 2 into 4. Okay, so as I said that this 4 is again the area which you have found out, pi d square by 4. So it is a matter of simple substitution. You can easily get the value of indicated power, find out what is the indicated power. We will get it in kilowatts. Now we need to find out what is the brake power. So we know that brake power is nothing but 2 pi mt divided by 60 into 1000. Now, if the dead weight load, spring balance load, radius of the brake drum, etc. were given, then we know how to find out what is the value of T. But in this problem, what has happened is the value of T is directly given. The torque on the brake drum is directly given. So there is nothing much to do. You will simply write this as 2 into pi into N is again 300 RPM. T is 250 divided by 60 into 1000. So you will get this in kilowatt. This also you have obtained in kilowatt. Now once you get the value of brake power and the indicated power, you can easily find out what is the mechanical efficiency. So mechanical efficiency is brake power divided by indicated power into 100. So you will get some percent. Okay. Now the next thing we need to find out is what is the indicated thermal efficiency and brake thermal efficiency, and we also know the formulae that need to be used in order to find out these efficiencies. So what we do is, suppose I want to find out indicated thermal efficiency. We know that it is indicated power divided by the specific fuel consumption into the calorific value. Now the problem in this case is the fuel consumed is given in kg per hour. Okay, so that has to be converted into kg per second. Okay, and we know that 1 hour is equal to 3600 seconds. So we have to divide that value 4.2 by 3600 in order to get it in kg per second. So we are simply going to, whatever indicated power we have obtained here, this value. So we are going to write that value here, indicated power. The fuel consumed is 4.2 divided by 3600 into the calorific value of the fuel is given as 41,000. So we write it as 41,000. This entire thing multiplied by 100 will give us the indicated thermal efficiency in percentage. Okay, so it is again simple substitution. So you have to be careful. As I said, in some of the problems, the fuel consumed may be given in kg per second, and some problems it is given in kg per hour. But our final, you could say, aim is that value has to be in kg per second. So in order to convert that into kg per second, I have divided 4.2 divided by 3600 so that I get it in kg per second. So this is the indicated thermal efficiency. Once you find out the indicated thermal efficiency, the formula, small modification in the formula. So brake thermal, you will write this as brake power divided by m into c. So you will get the brake power again in. So this brake power you have already found out here. Using this equation, you have found out the brake power in kilowatt. So you can easily get the mechanical efficiency, the indicated thermal efficiency, and finally the brake thermal efficiency. So this again is a very simple problem, matter of substitution. You only need to understand how to substitute and get the values correct. Okay. So now what I'll do is I'll solve problem number 10. Now that doesn't mean you can neglect all of the problems. Okay. So it will be your responsibility. Whatever remaining problems are there which I have not solved, you will have to solve them. You could probably take this as an assignment. Okay, so very neatly you will solve all the 11 problems, which will enhance your confidence, and I'm sure you will be very comfortable in attempting numericals in your exam. So you can take that as an assignment. Solve all the 11 problems on ruled or unruled A4 pages. And maybe you can upload them. I'll create a Google link. You can upload them, and that itself will be the assignment for your second assignment. There will be a separate question bank which will be circulated for your second IA. That has got nothing to do with this assignment. And from that question bank, I am not going to ask you to solve anything or write anything as a part of your assignment. Your only assignment is to solve all the 11 problems and upload them, convert them into PDF format and upload them. I'll create a Google link and share it with you. Now I'll solve problem number 10, which is slightly different. Normally such kind of problems are not asked, but when you look at the statement of the problem and when I tell you what exactly it means, then you will slowly start realizing that this is also something which can happen in engines, and how it is going to affect the working of engines and so on. I'll first read out the statement of the problem. Now the statement of the problem is something like this: a 6-cylinder 4-stroke IC engine. So first thing is, it is a 6-cylinder engine, and it is a 4-stroke engine. It develops 50 kilowatt of indicated power. See, here it is very clearly mentioned as it develops 50 kilowatt of indicated power. Directly it has been mentioned. In the previous problems, it was not mentioned. It was just said that it develops so many kilowatts of power. So there we assumed it as the brake power. But in this problem, it is clearly mentioned as 50 kilowatt of indicated power. At a mean effective pressure of 700 kilopascal, the bore and the stroke length are 70 mm and 100 mm respectively. If the engine speed is 3700 rpm, find the average misfires per unit time. Now, this is something very interesting. You know, we have not talked about this concept of misfire per se, you know, in our regular discussion. So what may happen is whether it is and this concept of misfire is especially observed when you have more number of cylinders. If it is a single cylinder engine, generally we don't have this concept of misfire. But if you have a 3-cylinder engine, 4-cylinder engine, 6-cylinder engine and so on, there can be this misfire. You need to understand first what is the meaning of this misfire. Now, what happens is, we know that the piston is reciprocating up and down, and we have the 4 strokes because it is a 4-stroke engine. So we have the suction stroke, we have the compression stroke, we have the power stroke or the expansion stroke, and then the exhaust stroke. And there is a rhythm in which they work. So if there are 6 cylinders, all the connecting rods of these 6 cylinders will be connected to the same crankshaft, one crankshaft only. And all of them are going to work in tandem. Okay, so if one is undergoing suction stroke, the other one will be undergoing compression stroke. Maybe there are 2 cylinders where power stroke is being generated and so on. Now, if it is, let's assume that if it is a petrol engine, just at the end of the compression stroke, what should happen? We know that the spark plug should give out a spark. Okay. Now, there are 6 cylinders. It may so happen that in one of the cylinders, due to some reason, at the end of the compression stroke, the spark plug does not give out a spark at all. Okay. Now, if the spark plug does not give out a spark, the fuel is not going to burn, but all other, you could say, steps will happen. All other strokes will happen. We may not have an expansion stroke. There is no power which is delivered from that particular cylinder to the crankshaft. But piston will still come down because the crankshaft is moving continuously. There are other cylinders which are delivering power. So that piston will come down and the exhaust valve will open, and what is pushed out is unburned fuel. Okay, so misfire means where there is no firing that takes place. And in fact, we don't want misfires because misfire will reduce the efficiency of the entire engine. So in case over a period of time we find that the efficiency, fuel efficiency especially, has come down, then we generally take it to a mechanic and tell that this is what is happening. So the mechanic will say, okay, I think there is some problem with the timing belt or the misfire. Because if there are 6 cylinders, obviously we can fairly assume that there are 6 spark plugs, and from the same battery, energy is being given to all the spark plugs. So you use what is known as a commutator. So the function of the commutator is to direct to which cylinder the high voltage has to go, 10,000 or 15,000 volts has to go momentarily, so that the spark plug gives out a spark. So this is the concept of misfire. So what are we supposed to do in this problem then? Now, because it is a 4-stroke engine, I'll just tell you what exactly we will be doing here. Because this is a 6-cylinder 4-stroke engine, now the engine RPM is given, okay, that is 3700 RPM. That is, the crankshaft is rotating at 3700 RPM. But we also know that power is delivered during every alternate revolution of the crankshaft, which means if the engine RPM is given as 3700, then the number of firings that have to take place will be 1850. Okay, half of this. Okay, that is the first thing which you need to remember. 1850 firings have to take place. Now what we are going to do, engine RPM is already given. So what we are going to do is, we are going to use the equation indicated power is equal to PM, LAN and so on. But in that N, we are not going to substitute the value of 3700. We will keep that value of N as it is and find out using that equation what is the value of N. So I'll first write down the data and then let's see how to solve this problem. You can again use a calculator at home and do the calculations. So it is a 6-cylinder 4-stroke engine, and it is developing total indicated power is 50 kilowatt. Then mean effective pressure is 700 kilopascal, which is nothing but 700 into 10 raised to 3 Pascal, and 1 Pascal is nothing but 1 Newton per meter square. Then bore and stroke length are given. So bore is nothing but 0.7 and stroke length L is 100 mm, which is this is 0.07 because it is 70 mm. So it is 0.07 meters, and the stroke length is 100 mm, which is nothing but 0.1 mm. Then N is given. Okay, so N actual is given as 3700 RPM. Okay, so we need to find out what is the average misfire per minute. Now, the first thing in the solution, actual firings per minute, okay, should be half of that, as I said, which is 1850. Now what we are going to do is, we are going to find out what is the indicated power per cylinder, and then find out what is the engine speed from that, and then check. Now, of these 6 cylinders, which one is misfiring, we don't know, but we can just comment that okay, there are so many average misfires per minute. So what I am going to do is, this is the total indicated power. So what is the indicated power per cylinder? 50 divided by 6, because it is a 6-cylinder engine. So 50 divided by 6, which is nothing but the indicated power per cylinder. Now we have this value, that is mean effective pressure, value given in Newton per meter square. So I will write the equation as 700 into 10 raised to 3, that is PM. Then L is 0.1 into pi d square, that is 0.07 square. Okay, I am not going to write the value of N, I will keep it as it is. Okay, I will keep it as it is, divided by, I will write this as 60 into 2 into 1000 into 4. Okay, because we already know 60 into 2 into 1000 for what purpose we are using it, and the value of mean effective pressure is given in Newton per meter square. This is the equation which we are going to use. This 4 has come because of the area. Okay. Now what we do is, using this equation, we can find out what is the value of N. Okay, so from this equation, we will find out the value of N. Now, if there are no misfires at all, let's say, then if I find out the value of N, this should be actually equal to 3700 RPM only. But it may not be. We don't know. So what we are going to do is, we will find out this value of N. And because again it is a 4-stroke engine, we will find out number of firings. Okay, so this will be N by 2. That is, whatever this N you have found out, N by 2. Okay, so it may not be 1850. It can be higher than 1850. It can be lower than 1850, and so on. But it can never be, of course, higher than 1850, because you will not have more firing than the actual speed of what is given. So we expect it to be slightly less. You can anyway do the calculations and find out what is the value of N using this equation, and once you do that, find out the number of firings. Now the difference between these two, okay, so the difference between this and this value, what you find out will be the number of misfirings per minute. Okay, so you just say that number of misfirings per minute will be, I really don't know, it will be 1850 minus whatever value you give, this value. Okay. So I have written it as a modulus because in case this is more, there is nothing like a negative sign for misfiring. So in case this is more, you may end up getting a negative value. So no, I don't want that to happen. So just find out the difference, that's all, which will give you the number of average misfires per minute. So per unit time is asked. Okay, so since n value is in RPM, that is revolutions per minute, this also will be in revolutions per minute. So you will have number of misfirings per minute, you know, which will be given by this formula finally. Okay, so for that you have to, as I said, understand what is the meaning of misfiring, and we have only found out what are the number of misfirings per minute, but in which cylinder these misfirings are occurring, we don't know anything about it. It is just a matter of wild guess. Okay, so let's not worry about all that. Okay. Now again, what we will do is, even though these are the question paper problems, I'll once again go through a couple of books, and if there are problems which are again slightly different from what we have solved, where additional information may be needed, we will solve maximum of another 1 or 2 problems and then conclude this module. But as I said, as a part of your assignment, you are all required to solve all these 11 problems on A4 pages, ruled or unruled. I leave it to you. Convert them into PDF and you will upload them. And your second eye test dates have not yet been announced. Okay, so today is 2nd of July. So what I expect is maybe by 10th of July you will be uploading the solutions for all these problems, which will be your second assignment. 2 things will happen. One is, of course, it is an assignment which carries some weightage and marks. Second thing is the problems which I have not solved in these 11 problems, when you solve them on your own, it is going to increase your confidence level. Okay, so I suggest sit down calmly, and at any point of time you don't understand, or if you face any kind of a difficulty, you can always message me and get your doubts clarified. So effectively we will say we have actually concluded the second module. But as I said, if there are any other interesting problems which are slightly different from these, we will try to address them also, and then conclude. For that, what I may do is I will solve those problems. I'll record it and put it directly on the YouTube, and then send you the link so you can see those and try to understand the solutions to those problems. I may not take one additional lecture for that. Okay. So what we may do is we will start with the next module from the next class onwards, which will be all about machine tools. Okay, which is again very interesting topic. So machine tools, I think it is module 5. So we will be starting with module 5. We have now finished module 2 and module 3. We will be starting off with module 5 from the next class onwards. Okay, fine. Yeah, thank you very much.